video retrieval. So we briefly see how immediate video retrieval can work and how it can actually solve useful problems. Now I will touch upon a couple of applications where how this video retrieval technique along with something else can actually provide some interesting applications. So first application is that of a video filter. What is a video filter? It is, in fact, you have a continuous video coming and you want to filter out certain content out of it. Sometimes an objectionable part of the video has to be censored, cut, removed automatically. So this is the problem. So the online content-based processing of continuous stream of videos. So it's a content-based processing, but in the online video is processed to detect video segments which are similar to a given set of examples. So you are given now examples. So in the previous case, if you remember, you have a huge video collection. Okay, I'll just show you the difference between video retrieval and video filtering. In the case of video retrieval, you have a huge video database, and you give an example video, you can retrieve it. In the case of video filter, it is absolutely the reverse of the problem. You have few examples available a priori. I don't want any objectionable scene to be streamed through my channel. My examples are given a priori, but my online video is never indexed. It comes, it gets processed, and it goes out. So it's an absolutely reverse situation where the database is small in the case of video filter, but online video is huge. While the case of the video retrieval, video database is huge and query videos are small. And we use this for filtering large amount of video data. So one example is, for example, advertisement removal. We have few advertisements which you want to remove. So you have a database of advertisements, and as and when a new video comes, it detects that okay, then such a video has come with a minor modification, and then it needs to be removed. So it requires an indexing scheme that is capable of indexing a priori available small sets of examples. So examples have to be indexed, not the online video. While in the case of the previous one, the whole video database was indexed and example was a query. So which in a way can be understood as simultaneous online spotting of multiple examples in a video stream. So you want to do multiple video spotting. So I have 100 examples and all 100 of them will have to be spotted to it. So what do we do? So our solution is based on a data structure called try. So we build a vocabulary try. So this vocabulary try, so when a new video comes, it looks at the root. I don't know if you're familiar with the try data structure. It's very similar to the trees. This is with a minor difference where when the data comes, it comes at the root and looks for whether this matches. If it matches, it goes to the next, and when it reaches the leaf node, it says that okay, there is a example 1 is C. So try statistics is very popular, for example, as a spell checker in word processing, word dictionaries, etc. for checking the correctness of a spelling. So a certain data structure and a vocabulary framework is used for building a vocabulary try which removes the video, which says that again your example 1 is seen, example 2 is seen, or example 3 is seen, and it removes it. So what we do is that we demonstrated 3 applications in this. One is a commercial removal, the second one is content-based copy detection, third one is action spotting. I'll skip the results of these 3 and I'll get into the next application, which is multimodal retrieval for cricket videos. The next application is, the retrieval is fine, like we build a broadcast video indexing system. So you have a video database. But your user is expecting text notes. So what is our problem usually? Given such a huge a cricket match, I would like to ask a question with something like, how did Jawahar keep calling out our video? Okay, my requirement is very specific. And one video retrieval system is not able to. Even if I am able to retrieve bicycles, even if I am able to retrieve batsmen, even if I am able to identify sixers, I'm not able to connect all of them and provide very meaningful answers to this question. So your user expectation is very high. What can we do? Why this is difficult? Because if you look at the video in cricket match, it is all sort of noises, advertisements, animations. And if you look at IPL, that is still worse. Half the time goes in advertisements. Okay, so now how do we actually make some sense out of whatever is coming there? There's a very useful solution. It's something called cricket. Half of us also use cricket or similar things for understanding cricket. What do we do? What is this? This provides the online version of the match. It provides you commentary of the match. And if you come for a commentary, so it has very clear description of how it Jawahar did 6 of. So there is one modality of text. There is another modality of image. User is asking question in text, but user wants an answer back in image. There are two different modalities which needs to be synchronized. So what if you carefully see this parts this commentary again, you see it says what's the ball number, it says who's the bowler, it says who's the batsman, it says what's the outcome, and it says what how you do it. So if you are just building a text search engine, it is fairly straightforward. I can get text answer. But now my problem is that I have a video. I have a video where core input is bowling and Sehwag is hitting six. I have a commentary here in a separate modality. These two are not aligned. My task now can be formulated as an alignment of text and image. My text comes from cricket form, my image or video comes from Dish TV, and I need to just align them. Once I align them, search engine is done. Text search engine was retrieval in video. Lack of synchronization between text and audio is my challenge. And how do I do that? So how to model this text? So what we do is we convert this text into a video, a virtual video. So you cannot align a text and video, which are two different modalities. What we do, we convert both into a different representation, a feature representation, where there is a stream or a string which corresponds to the text. There is another string which corresponds to the video, and we would like to align both of them. And